What's up, y'all? It's Mr. Canada. In this video, we're going to be learning how to solve linear inequalities. We're also going to cover about how we read inequality signs and how to check if a point given to you is a solution to the inequality. Let's get started. So before we even start talking about solving inequalities, it's important to know how to read inequality signs. Now, what are inequalities to begin with? So inequalities are basically these symbols that compare the quantities that compare whether one quantity is greater than the other or less than the other. You might have seen these symbols. It's the greater than sign, or the less than sign, or the greater than equal to, or the less than or equal to. How you read inequalities is very specific on the context that you're working with. So for example, let's say that you're comparing the number 10 with the number 4. There are two possible ways that you could read this inequality. You could read it as either 10 is greater than 4, or you could also read it as 4 is less than 10. So there are two possible ways of reading the same inequality symbol. Now, when we start incorporating these symbols into algebra, we are going to be focused on reading the inequality based on where the variable is located in your problem. So for example, let's say that you had something like this. How would you go about reading that? You're always going to read it based on where the x, or whatever letter you're working with, is located. So because the x is located on the left side, the correct way of reading, or the appropriate way of reading this inequality, would be the following. X is greater than or equal to 4. It would not be a good idea or be recommended to read this as 4 is less than or equal to x. The moment we start incorporating algebra into our work, you will always read your answer based on where the variable is located. So that means that if the variable is located on the left side, make sure that you're reading this as x is greater than or equal to 4. Or if you have the x on the other side, like let's say you had it like this, then in this case, you would read it as x, because it's on the right side of the inequality, is less than or equal to 4. So again, how you read the inequality is very dependent on which side of the inequality you're working with. So always keep a lookout to where the variable or the letter you're working with is located. That's going to be such a huge help in reading or knowing how to transcribe that answer. So one thing that you should know about linear inequalities is that all the rules that you know about solving linear equations is going to apply to these types of problems. That means that if you have to distribute something, go ahead and distribute. If you have to combine like terms, go ahead and combine like terms. If there's variables on both sides, move all the variables to one side. All of those rules, all of those simplification techniques will apply to these types of problems. But there is one little small detail that you have to be aware of. And let me cover what that detail is. Let's say that you're working with an example like this one, where you have negative 2x plus 3 is greater than or equal to 13. Again, this is greater than or equal to because the x is located on the left side. So how do we solve this problem? Well, we would solve this problem like we normally would. We would subtract 3 on both sides. We would have negative 2x is greater than or equal to 10, and then you would still divide both sides by negative 2. So all of the techniques that we've been doing so far is going to be applying here. All of the techniques that we know about linear equations is going to apply here. So after we divide by negative 2, you're going to get an answer of negative 5. But then this is where the little nuance comes into play. Any single time that you divide as your last step in your inequality, you always have to make sure that you flip the sign of the inequality that you are working with. Now, why are we doing that? Why all of a sudden am I making up rules? There's a really good reason as to why we flip the inequality. And let's use the example that's given to us here. So let's just assume that we didn't know that we had to flip the inequality and we kept it the way it was. This is saying that any value of x that is greater than or equal to -5 will satisfy this inequality. So let's go ahead and test it out. What's a number that's bigger or greater than -5? Well, let's just go ahead that I decide to use the number 10 in this case. 10 is always going to be bigger than -5. So let's check if the answer of 10 works for this problem. So -2x plus 3 is greater than or equal to 13. If you plug in 10 for the value of x, look what's going to happen. -2 times 10 plus 3 is greater than or equal to 13. -2 times 10 is -20 plus 3 greater than or equal to 13. And if we add these two, we get -17 is greater than or equal to 13. This is where the problem occurs. -17 is not greater than 13 by any means. Nowhere close. So what exactly happened? We did all the work, right? Why doesn't the answer that we chose actually work out in this problem? And the reason for it is we did not flip the inequality. By flipping the inequality, then we're setting ourselves up for success in giving them an answer or giving us an answer that works for this particular set of problems. So why do we flip the inequality? If we don't flip the inequality, when you divide by negative, you're going to get a portion or a group of answers that do not work for the problem given to you. So it's always important that anytime you divide by a negative, that you make sure you flip the inequality to the other side. So one more time. So any single time that you divide by a negative number, you have to flip the inequality. It's going to be facing the other side. And again, if you need a reason, this is the reason why. We can choose an answer and it will not work if we don't flip it. Besides that, all of the rules that we know about solving linear equations will work. So what we're going to do, just to build up our confidence here and just to see if that's true or not, let's do a couple of examples that we can use our simplification techniques on. So here's the first example. 2x, or 2 times x minus 3, is less than or equal to 10. We have parentheses here, so it's always a good idea to distribute here first. So 2x minus 6 is less than or equal to 10. After this point, we have a two-step equation. We can use our inverse operations to solve this problem. So we can add 6 to both sides. We're left with 2x is less than or equal to 16, and then we divide both sides by 2. We're left with x is less than or equal to 8. We do not flip the inequality because we did not divide by a negative number as our very, very last step. So this is your solution. X is less than or equal to 8. Okay, let's look at the next one. We don't see any parentheses here, so we're probably not going to distribute. But there is a couple of things that we can combine here. Here, we can combine negative 2x and negative 4x, which if we combine like terms, that gives you negative 6x. But that's not the only thing we can combine. We can also combine this plus 8 and this minus 2, and when we do, we get plus 6. And now let's go ahead and bring down the symbol. From here, we go ahead and use our inverse operations to solve this equation. Minus 6 on both sides. We're left with negative 6x is less than negative 42. And now because we're dividing by a negative number as our very last step, we're going to make sure that when we simplify our answer, that we flip this inequality sign. So now it's facing this way because we divided by negative 6, and all we're left with is 7. So your answer is x is greater than 7. It's not equal to because it does not have the equal to bar at the bottom. So again, these are pretty much similar to linear equations. The steps are the same, the techniques are the same, distribution, like terms, etc. Let's go ahead and do another example here. In this case, we have variables on both sides. so we have to decide where we want to move everything. I feel most comfortable moving all of my variables to the left side of the problem. So we're going to move this x by doing the correct inverse operation. The correct inverse operation is minus x, and we're also going to subtract x with the 3x because it's an equation still. So from here, this cancels out. 3x minus x is 2x. Here we bring down that plus 2, the inequality, and then negative 26. Now from here, it's a two-step equation. We subtract 2 on both sides. We're left with 2x. Inequality symbol is negative 28. And now we're going to go ahead and divide both sides by 2. Now, just because your final answer is negative does not mean that we're going to flip the inequality sign. Remember, the only time you flip the inequality is when you divide by a negative number as your very last step. So just because the answer is negative does not mean we're going to flip it. So this is going to stay the way it is, but we do end up with a negative 14 as an answer. And this you read as x is greater than or equal to negative 14. So again, the techniques that you know about linear equations is going to apply here. It's not going to be anything different. Now there is one more thing I do want to cover with you guys, and it's about how do we check whether a solution given to us is actually a solution to the inequality. This is really simple. All you have to do is plug in the x and y given to you, simplify a little bit, and then check to see if the remaining answer is true or false. So check this out. We're going to check to see if this point, 2, 3, is a solution to the inequality 2x minus 3y is less than or equal to negative 2. So how do we actually go about that? Well, all you have to do is take this x and plug it in here, and take this y and plug it in here, and then just calculate some stuff. So I'm going to go ahead and write it down one more time just to make it easier to work with. And all we're going to do is make sure that we're plugging the stuff in correctly. So 2 parentheses, what number is x here? Well, here they tell you it's 2, so this is going to be 2. Minus 3, what value of y are we going to plug in? Well, here they tell you it's 3, so we're going to plug it in there, is the inequality sign, negative 2. The only thing you have to do now is either mentally or by hand or using a calculator is simplify as much as you can. So here 2 times 2 is 4. Negative 3 times 3 is negative 9. And we're going to keep simplifying here. 4 minus 9 is negative 5. So negative 5 is less than or equal to negative 2. Now, is this true? Is it true that negative 5 is always going to be less than negative 2? Absolutely. The bigger that negative is, the smaller that number is. So this is going to be true. So therefore, this point is a solution to the inequality given to us. Look how simple that is. All you have to do is just plug in the numbers in the right spots, simplify, and then check to see whether your final answer is true or false. Let's go ahead and do it one more time. Here's our x, here's our y. This time we have the inequality of 2y is greater than 4x plus 5. So from here, again, all we're going to do is plug in the numbers into the correct spots. So in this case, what are we going to go ahead and plug in for y? Well, in this case, it's going to be 0. What are we going to plug in for x? Well, in this case, it's going to be negative 1. So 2 times 0, inequality, 4 times negative 1 plus 5. And all we're going to do from here is simplify. 2 times 0 is just 0. 4 times negative 1 is negative 4. And then we're going to go ahead and add 5. From here, this would be 0 is greater than, well, negative 4 plus 5 is just positive 1. So now here's the thing. Is it true that 0 is greater than 1? That's absolutely false. So in this case, we can say that this is false, and we can say that this is not a solution to the inequality. So what do we have to do here? Really just take the points that are given to you, plug them in, and then simplify. And then check to see whether the final answer is true or false. And if it's true, it is a solution. And if it's false, it is not a solution. Let's go ahead and recap real quick. So once you start working with inequalities in algebra, you're always going to read the inequality based on where the variable is. Solving inequalities is very similar to solving equations, all the steps are going to be the same. The only thing you have to keep in mind is when you divide by a negative that you have to flip the inequality sign at the very end. And then finally, an easy way to check to see if a point given to you is a solution or not is by just taking that point, plugging it in, and simplifying. And you're going to check whether the statement at the very end is true or false. Well, I hope you guys learned something new today. If you have any questions, leave them in the comments below and I'll get to you as soon as I can. If you liked the video, give the video a like and subscribe to my channel for more Algebra 1 videos. And as always, please take care and I'll see you guys next time.